So in this video, we are looking at graphing quadratic functions using the quadratic formula. Now these quadratics will be in the form of y equals ax squared plus bx plus c. Now we've talked about the axis of symmetry and the quadratic formula in previous videos, so I won't spend too much time actually proving them. We're just applying them here. Now we can find the equation of the axis of symmetry by writing x equals to minus b, so this coefficient of x, over 2 times the coefficient of x squared. Once we have this x coordinate, we can substitute it with this x value. We substitute it back in here to get a y value, and that will be the coordinate of our vertex. Now, the quadratic formula is x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. This will give us the x-intercepts of our quadratic function. Now, this bit under the square root has a special name. We call this the discriminant. And we can use this as a quick way to determine how many zeros or how many x-intercepts our quadratic will have. If this value is greater than 0, there will be 2 zeros. That kind of makes sense. If it's greater than 0, we'll get some number here. So it'll be minus b plus whatever this is over 2a and minus b minus whatever this is over 2a. If x equals to 0, then this whole thing will be 0. So it doesn't really matter whether I do plus or minus, I'll only get one unique solution, because adding 0 to b or subtracting 0 from b doesn't actually change the result on this numerator. So we'll only get one x-intercept. And if the discriminant is less than 0, we're going to get a negative under the square root sign. So that's going to give us a math error. We're going to get no real solutions. So this is why we say there are no x-intercepts, no zeros. Now going straight into this, we want to sketch the graph of y equals to negative x squared plus 6x plus 1. Now, first thing we want to draw our attention to is that the coefficient of x squared is negative. So we already know this parabola is going to be concave down. Now, we want to find the axis of symmetry. So we want to use this equation here, x equals minus b over 2a. Now here you can see I've substituted in those values. Minus b, I get minus 6, this coefficient of x, over 2 times, when we have a negative in front, we say it's negative 1. So 2 times negative 1. And that will give us 3. Once I know the equation of this axis of symmetry, I can substitute this x value into my rule to get a y value out. And once I do that, you will see I get 10. So y equals to negative 3 squared plus 6 times 3 plus 1 equals 10. So that means our vertex is this coordinate 3, 10. Now, once we have our vertex, we can find the y-intercept as well. The order doesn't really matter. You can find the y-intercept first, but we get the y-intercept by substituting in 0 in the x. So minus 0 squared plus 6 times 0. This just cancels out these terms. They cancel out to give 0. So our y-intercept is going to be plus 1. And we can find our x-intercepts by substituting into the quadratic formula. So x equals to minus b is 6, plus or minus the square root of b squared, minus 4 times a, which is negative 1, times c, which is positive 1, all over 2 times a. So 2 times this negative 1. So we get our two solutions here. Now I've got the solutions in exact form, but when it comes to graphing, sometimes it's a good idea to just write them in decimal form as well for your own reference to see roughly where you want to plot these points in. So now that I have all of the main features, I'm going to just substitute in my points. So we said the y-intercept was 1, so that's going to be here. We said our axis of symmetry was at x equals to 3. So that's this one over here. And our vertex is at the point 3, 10, which is up here. So we want to label in our vertex, and we know it's concave down. And looking at our x-intercepts, one is around negative 0.162, so that's going to be this one down here, and around 6.162, so that's going to be around about here. Now, once we have all of these key features, all we have to do is just connect the dots. So we're going to try to draw one smooth, continuous curve, hits the maximum turning point, comes back down. Messed it up a little bit at the end there, but we get this thing over here. But we can rub it out. and we get our nice little quadratic here. We have the y-intercept, so we can label that in. That's, our y-intercept, yep, that's 1. And our x-intercepts, when you're labeling them in, it's good practice just to write them in exact form. So 3 minus root 10, 3 plus root 10. And here we have our graph. Now we're going to try another one here. We want to sketch this one over here. Now I've already done the working out, but I'll talk you through it. So the coefficient of x squared is positive, so we know our graph's going to be concave up. We're going to find the equation of our axis of symmetry. So we're substituting into this equation here. So we get minus 6, be careful with your negatives here, over 2 times a. So I get my axis of symmetry being x equals to 1. So I get this guy over here. Now, I want to find the vertex, so I substitute in this x value back into my rule to find the y coordinate. So this gives me 3 times 1 squared minus 6 times 1 plus 4. I get 1 out, and I get my vertex being this coordinate of 1, 1. So I'm going to draw that in here, and I'm going to label it. And remember, the graph's concave up, so this is going to be a minimum turning point. Now, just by looking at it, I can see my minimum turning points here. Let's just find the the y-intercept while we're at it. So substituting in 0 for these x's, we'll just cancel these out to 0, leaving me with 4. So I'm going to get a y-intercept of 4. Now, just thinking about it, how this looks, we know this is going to be a concave up graph, so it's going to look like this. Already by seeing where the vertex is and knowing this is a minimum turning point, I already know there's going to be no x-intercepts, but we can verify this using the discriminant. So our discriminant is b squared minus 4ac. So substituting everything in, I get b, which is minus 6 squared, minus 4 times a, this 3 term, times c, this one. And this is going to give me negative 12. So I know there are no zeros because our discriminant is less than 0. Now, when we go to sketch this, I have the axis of symmetry here, and the graph is going to be symmetrical around this. So I can determine another point just by kind of reflecting this one over here, just to this side. So I get the coordinate 2, 4. And that reflects this coordinate of 0, 4, because it's the exact same distance from the axis of symmetry. Once I get this, I have all my key features, so I can just draw in my continuous curve. And it goes up like this. Now this will continue in both directions, and I have that graph. I have my y-intercept, I have my vertex labeled in, I've drawn in my axis of symmetry. You don't always have to draw in the axis of symmetry, but it is good practice just so you can see how the curve is going to look. And it gives you a good way to draw up symmetry on either side. Now, one last example is we are using the discriminant to find the number of zeros of y equals 5x squared minus 20x plus 20. So substituting into the discriminant, b squared minus 4ac, I substitute these values in, and that gives me 0. So that means that I only have 1 0. So using the discriminant gives us a really quick way to determine, before I graph anything, how many x-intercepts am I expecting? But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.